Let's talk about 3D printing, shall we? How's it going? Bizarro here with another test subjects video, and today we're going to talk about 3D printing and some tips, some tricks, some do's, some don'ts, and just some general thoughts on putting 3D printed parts into your attraction. So let's go to the bench and I'll show you some examples. I think the first thing we need to talk about is when we say 3D printing for attractions and escape rooms, what do we mean? Generally, what we're referring to is iterating things and also making housings, things the public will not be able to touch. And that is where 3D printing comes in very handy. That is where it's the strongest, in my opinion, here. These are some examples of things that were not failures, but they just weren't correct. And I've kept them because who knows when you'll be able to just glue them as agreeably onto something. But this was a coin, like a fake coin we had 3D printed to test out the size and shape of it here, like this. Now, this could very much go into an escape room with some paint and stuff like that and be fine. This is thick enough, the infill is enough, and if this was dropped, it's not enough for it to shatter or break or anything like that. So something like this could be used in an escape room. It is also very light, so it doesn't feel like metal. What I would actually do is I would probably cast this out of something like pewter into a silicone or something like that and make an actual metal coin if I needed to, but that's neither here nor there. These are housings here to put micro switches in. I was testing different sizes and stuff like that to dial that in there. This was to test to be able to fit a gemstone into a housing here that ended up being made into a much longer piece. So all I had to do was test the one hole here, and then I knew if I just repeated it, I was able to make a whole bunch of them. So again, iteration. This was just to test the size and shape of something, and then make this out of acrylic or wood cut on a laser cutter. Something that would hold up a little more, because as you can see, this is very thin, and a player in a room will just snap this in half. This one would never, I would never put something like this in an escape room because of how fragile it is. This was a piece for something, but it obviously didn't work, but here it is. And then these are just interfaces. Like this here was, I believe, to mount LEDs into here, and so this was to test out a shape. I think this was slightly too short or not the exact right shape, so I held on to it because who knows when I can use it again. And then this was for a Greek mythology themed room, and this was just decoration. The stuff like this is great, right? Because this was just trim. I can 3D print out my own custom trim and then glue this down onto a prop. And because it is permanently adhered down, nobody's probably going to mess it up because it's just going to be permanently affixed. So again, this is a great prop to 3D print that you can get into a room and it won't get messed up by the public. And also this here, this was a cap. This is another example. This was made out of what's called a silk filament, which looks like metal, but it is not. This is plastic. But this was a cap that went onto something else and glued on. And again, works fine because it didn't, if this was just like this in a room, this could be crushed, this could be stepped on. But because this was a part of something else that gave it structure and stability, this was fine in an escape room. But there are definitely things that you do not want to put in an escape room because they will fail. And let me tell you why. So when I say 3D printing, what most people picture is the little filament printers, the FDM, the ones that go back and forth and build stuff layer by layer. Now, there is also the resin printers that build things out of resin, and there is even nylon and other types of 3D printing processes that are out there. But the main consumer level one that everybody is mostly familiar with is the filament printers. Now, the problem with the filament printers is because they lay things down in layers, you have points of weakness on your props, right? So I believe it was this one here. You can see that because this prop was hollow, I was using it as prototyping. There's no infill inside of these walls. These are hollow, which you should never do. But for expediency, I knew this wasn't gonna be the final product. But because of that, when I push down on it here, you can see that breaks open, right? And just by pressing in on this, I can just snap this thing in two like this. So that is what can happen to poorly made props in an escape room, is they will just break on these striation lines. Now, obviously, there's a lot less of a chance if you have infill and things like that inside your walls and inside your props. Something like this here, this prop, obviously it would be very difficult to do. Now, if it dropped and hit the floor, it definitely increases the chances. But because of how bulky this is, and you can see here that it's got a lot of infill, like that has a lot of structure inside of it there. That's a pretty good infill right there. And infill is exactly what it sounds like. It fills in, and depending on the percentage is how much it is, honeycombed or whatever. So a 5% infill would be much larger squares here, as opposed to this, which looks like a, I don't know, 80% infill. This is a lot of infill in this guy here. So this here would hold up to rigors of an escape room to a degree, because it is still plastic. If it got dropped, I'm sure there are parts of it that would eventually break off, like the ears could get chipped off and things like that. But there are stronger filaments now. There's even rubbery filaments that exist that would cause this to bounce and stuff. But one of the things that we have found is people are less likely to drop your props. They're more likely to be careful with them when they're heavy, right? Because they pick it up and go, oh, this has real weight to it. We need to hold on to it with both hands. When it's lightweight, when a 3D printed prop is very light, I think people tend to be a little more cavalier with it, right? And also, it can just kind of fall out of their hands a little easier because they're not holding on to it as securely. And if it's top heavy or something like that, or they set it down, they're not as precious with it, I feel, as a heavy prop. And it's very hard to get a heavy prop with 3D printing unless you put something inside of it. And we'll go over how to make heavy props, but also still using 3D printing here in a minute. But that is the main reason 3D printing props are not necessarily recommended in escape rooms, is fragility. So let me show you a couple other things here before we get into some other processes and things like that. I'm going to show you what I prefer to use escape room printing stuff, and that is housings. This is a hook switch. Not a very familiar component, but it is one that you have probably used a lot in your life, depending on how old you are. A hook switch is what goes inside of a telephone hook. It is the thing where when you hang up the phone, it lets the phone know if the receiver is on the hook or not, hence the name hook switch. And these come in handy for a lot of stuff, and because they're made to be hung up and picked up a lot, they're pretty durable. And as you can see here, their mounting options are not great. There's like two tiny little holes here on the sides, but I do not find that to be incredibly useful personally. So I created this housing for this to go into. Now what this is for is to mount it underneath something, right? So to take a flat surface of some sort and mount it underneath like this, so then something could hit it like this, right? And I'll leave a link down in the description of where you can get this in this particular little housing here. I put it online to share on a Cult 3D a while back, as well with the micro switch housings and a few other housings I've made as well. But so it was the starting process for this concept of a project I'm currently working on. And so I thought, okay, I need 5 of these in a row. So what do? All right, so I iterated this. I made this right here. But as you'll notice with these pins, you need this to be kind of lifted up because of these pins here. This is where your wires go. And I needed it to be lifted up a bit for access to the wires, but also to be able to meet the component that pushes down on the switch. So I then 3D printed some legs here just to get the length dialed in, and I had glued them onto here on another version of this, which I don't know where it is, but I glued some of the legs on here just to test. And once I got all of that done, then what I did, oh, and this is the top, by the way. So the other thing I did was I made a top that could screw down like this. This whole thing goes together and then gets screwed into a board. The top here, and the reason for that is should this switch ever fail and need to be replaced, then you could remove the top, pull this out, and replace the switch very easily. One of the things that I'm a big believer in is when you design props, you should keep maintenance in mind. Don't make something permanent because either you or the person behind you will have to come in and fix the stupid thing at some point. So, and also I realized these holes were too small here for mounting. So in the final iteration of this, as you'll see here, move this out of the way, this is what we came up with here, and it holds 5 of these switches. It has legs like this, and this was 3D printed like this. The orientation of the bed was like this. A lot of printers nowadays have really good what's called bridging, where they can just, in space, kind of print this way without needing supports. So I didn't need any supports with this housing, which was great because my printer is pretty awesome. But most modern printers can do this. So this was how I iterated that. And this also, very similarly, was something that I was working on that's part of it. This goes above it, and then there's a piece that slides down and hits these switches. And so initially what I had done was I had made little bumps here that I thought would lock into place in the slot. Then I realized that was a terrible idea because it just was. And most things I feel should be mechanically attached in some way if you can, just because people aren't trustworthy. And that's where this one came in. You can see the design change where I rounded that off, added recessed screwed holes so the screws will sit flush with this and look all pretty and stuff like that. And the other thing that had to happen was on the sides here. So you'll notice there's no channel here on the sides of these. Well, because what's going inside of this track is a acrylic, a clear acrylic with some engraving on it, what we decided was we wanted to embed LED strip down the center here, some of this stuff, like that. So I went into my 3D modeling program and I 3D modeled a channel into this. So I can slide as you can see here, we'll open this up for your convenience. There's just a kind of a hole along the sides there. There's a slit along the sides so the light to come through, and this just goes right inside. So I wanted to show you all that to show you the process of how we use 3D printing ourselves and how handy it can be for things like this. For creating interfaces and housings and stuff like that that the public can't really mess with. But what if the public has to mess with it? Well, here's what I suggest. So if you have props that need to hold up to extreme amounts of punishment, here's where 3D printing can come in handy. What you can do is you can 3D print the prop first, get the size, get the dimensions, make sure it works, maybe put it in your room for a couple weeks to make sure that it works as a prototype, and then you're going to make a mold of it here. So here is a 3D printed key. As you can see here, I designed this in my 3D program, and then we printed it, we painted it, this just got primer on it, and then we made a mold of it. And you can see here, this is the silicone mold here like this. This is actually one of like 3 different molds. We tried a handful of different types of molds to dial in how we wanted to build this. And you'll notice it has a recess in it. And the reason for that is where an RFID goes. And then this recess here lets us press a jewel over that. So it looks like a key heart locket kind of thing, but it lets you hide an RFID tag in it. And if you spray paint it gold or cast gold powders into here, it comes out looking metallic, right? So there's that. And the reason, of course, I didn't cast this in metal is because metal and RFID do not play well together. So there's that. This here is a 3D printed boat for an attraction here in Las Vegas, the IT escape room. And so these 3D printed boats, obviously, we know how thin these walls are over time. These get dropped, these get messed with, and because of the striations here, they just start to chip and fracture and things like that. And they have to have magnets inside of them. And you can do what is called print in place. With some of that stuff, you can 3D print a few layers and then stop the print, put a magnet in there, and then continue the print over it to a degree as long as the print knows that, right? But having a magnet and a metal hot end sticking to that, not exactly the easiest thing to do. So what ended up happening is made a mold of this 3D printed boat, and then we embedded magnets into it as it was curing. And now the other thing about some of the 3D printed parts with magnets in them is they can pull out and break through the plastic because of various reasons. If somebody sticks it to something metal it shouldn't, and then it rips out. So to, again, having it be a more indestructible resin is much more preferable like that. And I'll show you a couple others here. Here is video of a Shabti doll. And that was based off of, again, a 3D print. We 3D printed it, made a mold, as you can see here. Here's the mold one more time. You can see here, this is just using T20 mold star, I believe, from Smooth On. If you don't know Smooth On, you probably have seen their stuff before online if you are into any of this. This box and these blue and yellow bottles are very familiar to a lot of people. And so this is the kind of resin that we make everything out of. This is called 65D. Now there are other versions of this. You get what you need, but what you want is a semi-rigid resin. And what that means is it has some give to it, right? So the boats we made had this kind of flex to them, but because they are a resin and not a printed, they don't have the structural weakness. They just kind of bend out a little bit. But if you were to drop this off the top of a house, it would just kind of bounce, right? It wouldn't chip, it wouldn't fracture or crack or anything like that. So most everything we make out of resin is going to be out of this 65D. And like I said, the same goes for this Shabti doll here. We just poured the resin inside, and the Shabti doll had to have a magnet embedded in it. So again, you pour your resin, you pour it up to a certain height, let it kind of cure, stick the magnet in there, pour a little more, and now that magnet is embedded inside and is not coming out of the prop. And of course, you can do things this size in resin. Obviously, the technique for it's a little different, right? So this is what would be called a block mold, right? Because it is a large block of silicone. And this is a two-part mold. We use these to make ocarinas that had to have RFIDs inside of them because, of course, it did. That's our life. And so to do this, we had to create what's called a two-part mold. You pour the resin in this side, you pour the resin in this side, you kind of let it cure, you stick the RFID in there, and then you stick them together, and eventually out comes a cool thing. Now, real quick, I will show you the reason this is weirdly gray here on the edges is one of the cool things you can do, especially with a two-part mold like this, is you can spray primer. You can spray primer into these molds, and the resin will just impregnate with that primer and come out with it already primed and ready to be painted and stuff like that. So that's why there's all this gray stuff caked on here. The other thing you can do, which I mentioned earlier, is you can take a metal powder or a metallic-looking powder, and you can brush it into the inside of your mold, and when it comes out, the resin looks metallic or shiny, or you can use mica powders and have it look color shifty. There's a ton of cool tricks you can do with this stuff. And for those of you who do not know how to do mold making, this is not the video for that. There is a ton of information online, and again, this company here, Smoothcast, has all sorts of tutorials for anything you would need. And if you were going to do a bust like this, a 3D printed bust like this, you would do what is called a brush-on or glove mold to make it more cost-effective. Because the larger props get, you don't want to end up doing a block mold because that becomes extremely expensive. A brush-on mold is what you want for something like this. But again, once this is poured out of resin, it becomes heavier, and people treat it with a little more respect, I feel. So this is the solution if you want to make 3D printed props, but you want them to last in your room, is to learn how to cast them out of resin. Now, the other thing I will say, obviously, is if the public can't touch it, if this is on display on a shelf and it's like glued down, screwed down, or it's behind the plexiglass in a display case, knock yourself out. 3D print to your heart's content. Do crazy stuff. I recently had to help a company make an animatronic of a little 3D printed alien here in town, and he's behind a glass case. You can't touch him, so he's 3D printed, and there's nothing wrong with that. So just keep that in mind. What is the use for, right? Is it for display? Is it for handling? What is the prop doing? And that will kind of dictate what your next step is when it comes to 3D printing your props, because there is nothing better than being able to print your own stuff, paint it, make it look sexy, and then just put it in a room and people look at it and go, ooh, ah, that's awesome. So again, things just to keep in mind when you are creating these props for your experiences. Now, talking about 3D printed parts on display, I want to show you this magnificent thing here. All of these buildings that I'm showing you, except for this spire in the center, all of these have been 3D printed. Now, they were printed with a high density, infill, and on high quality, so the striations are very tight, and then they were spray painted this stone texture, and they were glued down within an inch of their life. That way, they do not move. That way, people, if they come to pull on it or mess with it, they're pretty solid, right? Especially this guy in the back. This one is very solid. Like, this is not going anywhere. Honestly, I will say, I'm a little surprised that this one survived, but it's a testament to how well this was 3D printed. This map was in a room for a number of years, and nothing ever got broken on it. Nothing ever happened to it. It survived, and one of the reasons for that is the fact, again, these are 3D printed at a high quality, but they're also glued down. So if somebody tried to move it, they'd sit there and go, okay, well, this doesn't move. And the clue for what this puzzle was is very obvious, right? They just have to look at this. They didn't have to touch it. They didn't have to do anything with it. So this is another case where you can use 3D printing in a room, but only if it's not going to move and doesn't have thin, tiny, little breakable parts.
So finally, I want to show you the program that we use to design 3D models and things, and this is called Shaper 3D. And as you can see here, I've designed a lot of different things. I even designed puzzles and things as layouts and concepts inside of the program itself. But for the sake of what we're doing here, I'll show you just how easy it is to create something. So if I need a very particular receptacle here, I can create there we go, I need that as the center. I can create this right there, and then I can extrude it, and then if I need this to be hollow, I can then make this hollow there, and if I need holes on the top of it there like this, I can make a hole just as quickly as that. Now obviously I am going fast here, but I just want to show you, if you know all the dimensions of what you're making, you can make stuff very quickly. Let's say I wanted to mount something on here like this. If I wanted to mount some sort of like flange or something of that nature like this, I can do that, and then let's see, we'll mirror this here. Hold on a second, let me do that. There we go. Mirror this, put that on that side, and then now I can drag this out like that. So then I created kind of a flange. And there's a ton of other stuff you can do with this program. It's pretty intuitive, and you can work very fast in it. It makes prototyping very, very quick, which is great. Now, this is a subscription-based program. It's $200-something a year. So if you think you're going to use it a lot and all the time, I absolutely recommend paying for it. Or if your company can pay for it, even better. But there are free programs out there, such as Fusion 360 and also TinkerCAD is what I meant to say. TinkerCAD is a free browser-based 3D modeling program here. And as you can see, I've designed a lot of stuff in it because there are certain things. This is what I started with. And so there's a lot of things that I still will sometimes resort to this if I need to modify certain types of files. But I've designed a lot of stuff in this, like very intricate things. As you can see here, this was cobbled together by a bunch of different 3D models. So this thing was made in TinkerCAD. This is something we use in a escape room currently. It's a bead. So this actually has, it's a two-part. You glue two of them together and it's the end of a cord. So this little 3D printed scarab thing here, you run a cord into this and knot it off, glue it down. Works great. A good example of 3D printing working in a room with no problem. These work great. And this is what I showed you earlier, that bird model I showed you. This is how I made this. I brought in just a sketch, and then we extruded it, and I put this hole in the center, and that's how that worked. Now, where do you get 3D models from, I hear you asking? Well, that would be over here, places like Thingiverse. This place here has all sorts of stuff that people have made for free. And you find almost anything you need, and a few things you didn't know you need, like small glue gun holder. Look at this guy. Isn't that sexy? I might 3D print that from myself. And of course, places like I mentioned earlier, like Cults 3D, same thing. They have 3D models of different things that people have uploaded. You can find different 3D models that are for sale, and a lot of them are for free. So you can get these kind of places. And if you just don't want to design stuff, and of course, there's things like Nomad Sculpt. If you want to kind of try your hand at sculpting in 3D space and making your own models, there's a lot of options for stuff, so you don't have to necessarily do it from scratch. But being able to do it from scratch in a program like this is very, very handy.
Hopefully this video will help you streamline putting 3D printed parts into your attractions and escape rooms, or not, depending on what you were planning on doing with them. And of course, if you have any questions or anything like that, feel free to hit us up at testsubjects.com. And you can also leave comments down below, and we'll be happy to talk to you there. And if you want to see more of our weird, fun, educational, and otherwise just helpful videos, feel free to check these out here. Click on one of these videos, and we will see you next time.